Welcome, this is Algebra 1-1, Unit 4-5, practice for the final. Mostly this is test taking skills. I will remind you just of a couple things that we learned during this unit. And I just want to make sure that you have notes for those couple items that are really major concepts. But if you need to review more of the concepts, go to the Unit 4-5 notes in the video selections. This is just really for test taking. So these are two major concepts I want to remind you of. Is solution to a system is the point where the line crosses. System is when two or more lines are on a graph. Okay? So the system is when there's two or more lines. The solution is the point at which those lines cross, like there. That would be the solution in those two pins. Okay? I need you to pause the video, write those into your notes. You'll need that for the test tomorrow. Now, when you look at the different possible solutions to a system, these are our possibilities. This has one solution. Because there's one point at which it crosses. This one, these are parallel lines. So it's no solution. They'll never ever share a point. And this one, it's actually the same line, and so they share all the points that make up these lines, which is an infinite number of points or infinitely many solutions. Okay, now I want to just add to your notes, pause as you need to. You notice on this first graph that the rise and the run is different. That's always true. Their slopes are different. So if this is line 1 and this is line 2, slope of M1 if line 1 is different from the slope of line 2. They're not equal. That's always true. Okay? Now, their y-intercept could be equal if it did happen to be on that point. So we can't say anything about the y-intercept really. Okay? Remember, I'm talking when they're in the format y equals mx plus b, our most common graphing format. So the m will be different. I'm sorry, I almost got that wrong. The m will be different when they have just one solution. The b may or may not be the same. Okay, when there's no solution, do you notice how the rise and the run is the same? You rise up, on this one it's about 2 and over 2, or 1, 1. So you rise the same amount. Their slope has to be the same. Because if one line shifts to a different slope, a different rise or run, in order for this one to be parallel, it has to have that same slope. So on this kind, I'm going to write in black, I like that black line better. So on this kind, the slope of line 1 is the same as the slope of line 2. Okay, so this being line 1, this being line 2, the slopes are the same. Interesting though, the y-intercepts cannot be the same. So the y-intercept absolutely may not be the same. They can't cross at the same point. So your y equals mx plus b, when you look at the two equations for the two different lines, the slopes would be the same, the b values would be different. Okay? On this last one, infinitely many solutions. I'm hoping that you're saying, well, obviously their slope is the same, because it's looking a lot like parallel lines that have just come together. This is M1, this is M2. We just show it with two arrowheads. Now, obviously, since it's the same line, their y-intercepts will also be the same. Same line, it's the exact same equation. Okay? So that will be vital. Pause the video, get all that in your notes. Now let's go to number 47. Let me pull in my camera view just a little bit. Hopefully you can also pull it in some. Okay. Try to hurry through these a little bit faster than the last video. I apologize how long it took. What is the solution of the system? We just talked about the solution is the point where they cross. Circle that and just find what the coordinates are for that point. We go to the right 2. The x value is 2. If we come over here, this is the only one with the x value of 2. So that is your answer. Next question. Approximate the x value when f of x and g of x are equal. Well, f of x is a formal name for y. G of x is a formal name for y. What we're saying is that it's the g of x line, whichever one it might be, and the f of x line, the function of x. So on these functions, when their y's are equal, what's the approximate x value? Right there, their y's are equal. So we go up to the x line. It's at about -2.5. So there's that answer. Which equation would make this system have an infinite number of solutions? Oh, let's go back. Infinite number of solutions. The slopes have to be the same. The b value has to be the same. So let's locate that. The slope on this one is 1. So I'm looking for a slope of 1. Well, this one, the slope is always attached to the x, by the way. This one has a slope of 2, so it's out. This one a slope of 3, so it's out. This one has a slope of 2, it looks like, but do you notice how this does not have the y alone? We need to get the y alone, so divide by 2. That would become y equals x plus 2. That ends up being exactly the same. So what we just said in our notes is that infinite solutions would have the same slope, same y-intercept. So we know that A is our answer. Okay, number 50. The equations of 4 lines are given below. Which 2 equations form a system with no solutions? No solutions means that we're looking for 2 with the same slope but different y-intercepts. Remember, your slope is right in front of your x. Well, we have a -2, we have a 1/3, and we have a -1/2. None of those are the same. We need to get the y alone in this problem to see which one it is like. We know that 2 and 3 are not the same, so we can mark that option out. We know that 2 and 4 are not alike, so we can mark that one out. Generally, always on a math test, you can mark 2 out without doing any math. Okay, let's get the y by itself. Take x minus 3y equals 9. Draw the line, circle the y, we're getting it alone. We would subtract x from each side. -3y equals -x plus 9. Divide by -3. That cancels and we get y equals negative over a negative is positive, so it's 1/3 x. 9 divided by -3 is -3. But we see our slope is 1/3. That's the same as this one. So our line 1 and 3 are the same. Slope, that tells us that that's the no solution or parallel lines. They have the same slope. They don't have the same intercept. One's 2 and one's -3, so they're not infinite like the last problem. Okay, number 51. Which of the following is the solution to this system? Well, I'll be honest, you guys, they've graphed this line. I think it's real easy to just go ahead and graph these points and graph that line. So we have -1, 6. Go to -1 on the x and up to 6. 0, 4. 1, 2. Now draw a straight line there. Whoa, I've got to see what's going on there. negative 1, 6, 0, 4. Oh, I'm sorry. I didn't count right. 0, 4, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. Guess I'm trying to hurry too much. Okay, now we draw a straight line through it. And it says, which of the following is the solution to the system? The solution again is right here. My x value is 2. My y value is 0. And there's my answer. Okay? Next page. Which of the following is the solution of this system? Solutions of systems are pretty important. Go back to playing your game that we played in Unit 2, where we're trying to find the function, or you can actually go and graph these. That would be fine on a piece of scratch paper, just like the last problem. In fact, that might be the easiest thing to do even on the video. So let's just practice graphing these. Try to get it all on the board here for you. Okay, we go to negative 1, 4. Let me get this a little bit more broad out. Okay, negative 1, 4 would be negative 1, 1, 2, 3, 4. 1, 2, negative 2 would be 1, negative 2. 2, negative 5 would be over at 2, negative 5. Now we would draw a line through those. Always use a ruler. I've got lots of them in class. Okay, now, Now we go to the equation. Remember from Unit 2 how to graph an equation? We cover the x-intercept, y equals negative 4. We go to negative 4. 1, 2, 3. Now from there we count the slope. Negative 3 over 1, that would be, so we go rise, you always rise on a slope, rise 3, run 1 to the left because it's negative. And now we graph that line. And I think you're going to see that those two lines are parallel. Parallel lines from your notes that you took right at the beginning of this. Parallel lines are no solution, they never cross. So the answer to that problem should be D. Okay, hopefully this is not going too fast. Pause if it is. Which x-coordinate is in the solution of the system of equations? You have a couple options. You could plug in the x value, and when you solve for y, when you just solve and you calculate what it equals, it will equal the same thing in both equations if you have the right solution. You could do it that way. I will do it the way that I taught you in class in this unit, is to do substitution. This says that y is equal to 2x plus 7, so we substitute it right in there to solve for the x. We substitute it in for the y, so we have 3x minus 2 times 2x plus 7, parentheses closed, equals 12. Always substitute in with parentheses. Now we distribute. 3x minus negative 2 times 2x would be negative 4x. Negative 2 times 7 would be negative 14 equals 12. 3x minus 4x is negative x. Minus 14 equals 12. Trying to get the x alone, we add 14 to each side. We get 26 equals negative x. Need to divide by a negative 1 to get rid of that negative. So we find that x equals a negative 26. So in other words, another way you can do this is you could plug in negative 26 for x, and you would come out with the same y value in each equation. Okay? Next problem. Which y coordinate is in the solution of this system? So this time, we kind of need to solve for y by getting rid of the x's. It's easiest probably, at least in my opinion, to go ahead and solve for x and then plug it back in. So just like we did before, take that y value, plug it in here for y, so negative 0.5x plus 2 equals 3 minus x. Distribute this negative, so it's a negative 0.5x minus 2, as you multiply there, equals 3 minus x. Now, you've got an x on each side. Let's just add x here. And that's add 1x. That would wipe out. 1 minus a half would be 0.5x minus 2 equals 3. We want to add 2 to each side. We're trying to get that x alone. So we have 0.5x equals 5. Divide by 0.5. Divide by 0.5. X would equal 10. Now plug that value in to see what your y is. We have right here that you could plug it in either equation. It'll work. We have right here that y equals 0.5 times x plus 2. 10 is for the x, so we say half, or 0.5 times 10 would equal 5, plus 2 would be 7. Okay? You invited friends over to your house to watch a movie. You let each person decide if they wanted a snack on popcorn, which costs $2.50. Popcorn, $2.50. Or candy, which costs $1.75 per person. You spent $17.50 or $17.75 on snacks for 8 people. Write a system of equations that you can use to determine how many people had popcorn and how many people had candy. I taught you guys to do these in a table format, and that's probably how you'll recognize it, where we have a total over here, and we have, what are our other two variables? Candy and popcorn. Popcorn and candy. Okay? This would be a value equation, and this is amount. They always fall into these categories, so they're pretty nice to solve this way. So we know what total spent was $17.75. We know the total number of people was 8. Says the people who chose popcorn we should call P. And the people who chose candy we should label as C. So the number of people that chose popcorn plus the number of people that chose candy is going to equal 8. Now we can just go to the options and see if that's enough. This one, P plus C, is $17.50. That's wrong. This one doesn't even have that amount. This one doesn't have an amount. This is the only one that does. If you wanted to make sure that it's right, popcorn's $2.50 per person. So you would be taking the number of people that ate popcorn multiplying by $2.50. People eating candy costs $1.75, so $1.75 times C. And there's your other equation. Hopefully you were in class to do a lot of those in warm-ups. We did do quite a few. Okay, 2 different families bought general admission tickets to the Reno Aces game. One family paid $70 for 6 adults, 2 children. Another family paid $59 for 3 adults and 2 children. Again, make a table. We've got adults and children that we're talking about. And total. Now this time you won't have your amount or value equations because you've got two different families. So one family, it says they paid $70 for 6 adults and 2 children. The other family paid $59 for 3 adults and 4 children. Okay, it says how much does an adult ticket cost? Let's just label the adult tickets A, children's tickets C, and if you remember in class doing elimination, that's what we're going to choose to do here. We want to wipe out the children's option so that we can just solve for the adult because we're asking on the adult ticket. So what number would 2 and 4 both go into? It would be 4. All we need to do is multiply this 2 by 2 to get it equal to 4. We do want to multiply it by a -2 so that we can wipe out that value. So -2, you need to multiply by everything in that equation. -2 times 6 would be -12a. -2 times 2 would be -4c. -2 times 70 is -140. We add these together. 4c and -4c, wipe out. That was our whole goal. 3a and -12a would be a -9a. And -140 and a +59. Well, I would actually do this in a funky way here. I'd say 140 minus 60 is 80. Since it wasn't 60, it's 59. That would be 1 less there. That would be 1 more here, so 81. And it's a negative because the 140 was negative. -81. Divide by -9. And I find that I have $9 for the adult ticket. As I am just looking for the price. And we probably should have marked that on here that the A is the value of the adult ticket. C is the value of the children's tickets. Okay? Which is the graph of y equals 3x plus 4. I would hope this is an easy problem for all of you. We did a lot of these. Cover up the x term and just look at the problem. It says y is less than +4. That's your y-intercept. So we go to +4. That one's not even there. It's out. +4. That does intersect at +4. It might be our answer. This one intersects at +4, and so does that one. So they're all 3 potentials. Let's see what the next thing is. Our slope, 3/1. That's a positive slope. It should go up to the right. They're all going up to the right. Okay. Next thing that we're going to look at, less than. Less than we talked about is lower. It's lower than the graph. So it would be this one, but that one's out. This one, but not this one. The shading's wrong here. Okay. And we should mark that that was the y-intercept was wrong there. So now we're to these two. The only difference is this is a dashed line. That's a solid line. We look up here. That is for dashed. This symbol is for solid, and our equation has this symbol. So that's our answer option. Next one, which is the graph for this equation? Well, we need to get the y alone into graphing format. So we take 2x plus 5y is greater than or equal to 10. Draw the line, circle the y. Go up our PIMDAs. What's being added or subtracted to the y? Don't go right next to them because that means multiply when they sit side by side. So a little ways away from him over here on the teeter-totter. His side of the teeter-totter is a positive 2x. Get rid of it. That wipes out. We get 5y is greater than or equal to negative 2x plus 10. Now we're done with add, subtract. We're at multiply, divide. 5 is multiplied by y, so we divide by 5. This wipes out. We get y is greater than or equal to negative 2/5 x plus 2. Our y-intercept is plus 2. This one's at plus 2. This one is not. Mark it out. This one's at plus 2, and this one's at plus 2. So again, we have 3 graphs. This has an equals to sign, so that it should be a solid graph. This is a dash graph. That would be greater than. Okay, so we're down to these two now. The only difference is this one's shaded above, this one's shaded below. It says greater than. Remember, that means greater is up more. I read to you guys, or some of you guys, I love you more, the little kid's book, and the rabbit went way up high in the sky to try to show his dad all the love that he had for him. So it was greater than, it's up here. Okay, not down little and low. Next one. Sally wants to buy her friend a bouquet for his birthday. Let's go down to the question first. Which graph below shows the possible combinations of numbers of carnations and roses Sally can afford? Okay. Well, carnations cost $1.50, and roses cost $2.50. So I'll be honest, when I see this kind of a problem, I know that the maximum number of roses is right here on this axis because it's labeled roses. And first thing I know is that I'm limited by the amount of money I have. This shows me with the shading up here that there's no limit, that I could buy infinity number. So I know that's out. And this one also is way up there. I could buy any number of roses out there. That one's out. They're not reasonable. So this means that I can either buy 19 roses or 11 roses. I just look at the price of a rose. It's $2.50. I divide it into the $28.50. Move my decimals over. 250 will go into 285 one time. 250. Subtract 35, 0. 250 will go into 350 about one time. Be a little bit of money left over, but not much. I certainly can't buy 19 roses, can I? If you think about that, 2 roses would cost $5. So 5, 10, yeah, we're gonna be looking at maximum 11 roses. Okay, so that marks that out. It's too high up there. Which system of inequality models the graph below? Okay, this is where I use my technical reading on these graphs. I look at this, they're both dashed lines, so I shouldn't see anything that says equal to, and I don't. Okay, now this also says that my y-intercept is at -2 on that one, and -1 on that one. Got a -1 there. This one isn't in graphing format, so I'm not going to look at it yet. Oh, I just noticed something. Do you see how the slopes are different here? Let's see which slope is right. And this -1 intercept, that's the one that we're looking at. Would it have a negative slope or positive? When we rise, we go to the left to connect on the graph, so that would be a negative slope. That means that this slope is wrong for the line. And this slope is wrong for the line. We've got a negative slope. So now at this point, we're going to have to figure out which of these is correct. And don't try to look at what's different here yet, because we really need to have the y alone. So 2x minus 4y is greater than 8. Draw the line. Subtract 2x from each side. Negative 4y is greater than negative 2x plus 8. Divide by negative 4. Divide by negative 4. Divide by negative 4. Negative 4 goes in there one time. This would reduce, negative over a negative is positive, so positive 1/2 x. And 8 divided by negative 4 is negative 2. Now, one little thing that I want to emphasize here. We always had difficulty in class remembering that when we divide by a negative, we do something special with an inequality. When you do the subtraction property of inequality and you divide by a negative, you should flip that sign around. So that is saying that y is less than this line. This graph shows that y is greater than. It's up higher than the line. So this is incorrect. Oops. I'm sorry. This one up here is incorrect. That's the one that we were solving right here. So now, if you had time on the test, I would highly recommend that you go ahead and do the same process with this line as you did with this one and make sure that it does come out correct. By process of elimination, it certainly looks right. Okay, 3 more problems. Again, I'm showing you the test-taking skills that I would use, and some of it doesn't require all the math. Jesse wants to plant peach and apple trees in his backyard. He can find at most 9 trees. Each peach tree, or he can fit at most 9 trees. Each peach tree costs $60. Each apple tree costs $75. If he only has $600 to spend, make a graph showing the number of each kind of tree. Notice how we have peach out here and apple here? One thing I want to remind you of, it's just like the carnation problem. You can look at some of these and just see by the graphing that there might be some problems. This is telling me that I can buy as many trees as I want because it goes clear out to infinity. So I know immediately that one's out. Brings me to these 2, or these 3. First thing that I'd look at is how are my graphs different here? They seem to be having all the same line, it's just where the shading is. So let's look at our system. At most, we can buy 9 trees. Go to our table. We have apple. We have peach. We have total. Ah, my lead. We have total. That one is toast. Grab another pencil. He said that he can only fit 9 trees in his yard, so the number of apple, which is on Y, that's our number of apple trees, and the number of peach, which is on X, would be equal to 9 or less than 9. Okay? Then the cost, that's our value, has to be equal to or less than 600. The apple trees, they're going to charge us 75 for each of those. And for each of the peach trees, it's going to be 60. Okay? Get the y by itself. In the first one, y plus x is less than or equal to 9. You'd subtract x from each side. Y is less than or equal to negative x plus 9. Okay? So I would look first at these graphs. The y-intercept is at 9. It's this line here, and it needs to shade down. That is correct. This one could be correct. This one, it's not showing the shading from that going down. So that one would be out. Actually, this one, it's trying to show just a solution here. Oh, I see, solution to both. So we should look close at this, because we've got that coming off there, that coming off there. We're going to have to look at where it's double shaded, guys. Next one, 75y plus 60x is less than or equal to 600. We subtract 60x from each side. 75y is less than or equal to negative 60x plus 600. Now we divide each side by 75. And we find that y is less than or equal to negative, let's reduce this, 15 will go in there 4 times and in there 5 times. And 15 would go into 640 times, and 75 5 times, so that'll be equal to 8. And it's less than. This shading here shows that at the 8 we went up greater than. So that one's out. And this one shows on the apple tree line, we went greater than as well, so that one's out. Good thing we started thinking about the shading for the solution, because it's this one where they're both less than. This is not double shaded up here, this is not double shaded up there. So it's only down in here is your solution to both. The number of trees that you could get with combination. Which of the following points is a possible solution to the following system? Please graph this. This is just a flat line at -4. It's a solid line because it says it's equal to. It says greater than -4. I just draw a few lines. This one we need to get the y alone, so we would subtract 2x from each side. And we would come in here at +5. And -2x is our slope. So we rise 2 and run to the left 1 because it's negative. Now it is not a solid line because it does not have a line underneath. It's not like that. So if you do like I just did and you made it solid, just go back and dash it. Because remember, you don't get full credit just for having the right answer. You have to show the right work. Okay? It says less than, so we shade that one this way. Last one. We have 3x minus 6y is greater than 12. We subtract 3x from each side. -6y is greater than -3x plus 12. We divide by -6. Distributed underneath both of those. So we have y, because we did division property of inequality with a negative, we flip this. 2 negatives make a positive, so it's +1/2 x. -6 goes into 12 at -2. Sorry. -2. So we go to -2 on the graph. We rise 1. We run 2 to the right because it's positive. Positive slope. Again, that one shouldn't have been solid. You want to make sure and dash it. Sometimes it helps on these to use colored pencils so that you can see where their different shading is. It says y is less than, so we shade down here. And if you look right here, you've got 3 layers of shading. Right in the mix of all of those lines. They all went over that spot. Now we find the point that is inside of the triple shading. So -1, 3, -1 up to 3, that would not be that one. -3, 2, -3 down to 2, it would not be that one. 1, -6, about there, it's not that one. 3, -2, that's the one that lands right in the mix of all of the shading. Okay, very good. Very last one we're going to do. Notice how this one, again, is like the roses, the carnations, the apple trees, and the peach trees, but this one, I think because they're answering with words, might be a little bit easier. We may be able to get away from having to do all the graphing. It's vanilla and cherry. And it says an ice cream manufacturer is making these. The manufacturer wants to produce at least 40 gallons of ice cream and spend no more than $400. Looks to me like we're going to need a table. Vanilla, cherry, those are our 2 options. The cherry is on the X, vanilla is on the Y, and our total. Now he already says he only wants 40 gallons, so we put 40 here. Y plus X equals 40. Okay? He does not want to spend any more than $400, so at most $400. Oh, this should be an inequality too, because at most he wants 40 gallons. Now it says that the vanilla is $5 and the cherry costs $8. So here with the cherry, you're going to be taking 8 as its value. You'd multiply the number of gallons you have times the 8. 5 for the vanilla. And those are your 2 equations. What I noticed down here, though, it talks about, is it viable or is it allowable to produce 10.5 gallons of cherry, and then it goes into how many gallons of vanilla. So really, we don't even have to graph it. They're giving us a point and asking which of these works. Okay. Let's see what's different. It says that no, it's not viable here. So let's go to cherry, and let's go to 10.5 gallons. That's about 15. 10.5 gallons would be right around 10. And up to 55. It's right about there. That means it is in the solution set. So when it says no, it's not viable to produce this much, that would be incorrect because it's within our solution set. So yes, it would be viable. What's the difference here in these 2 answers? That's what you want to look at. It is possible to make partial gallons and the 0.55 and 10.5. Ooh, do you notice here? This is their X and this is their Y. This is their X and this is their Y. The cherry's on the X-axis. So we went 10.5 right here. So D would be your correct answer. Okay, you're done with the review for 4-5. I will see you in class tomorrow. Good luck on this test.